Welcome to Mass Academy. In this video, we are discussing physics examination questions for grade 9 advanced. In the first part of the video, we have discussed from question number 1 to question number 8, and this video we will discuss from question number 9. So we will start with question number 9. Question number 9, Ali, who has a mass of 43 kilogram. So mass is 43 kilogram. Mass of Ali 43.0 kilogram. Slides down the banister at his grandparents' house if the banister makes an angle 35 degree. So the angle made by the banister with horizontal is 35 degree. 35 degree. What is the normal force between Ali and banister? So we need to calculate the normal force. So to calculate normal force, what is given in the question? Only the mass and the angle is given. Mass of Ali and the angle made by the banister with the horizontal is given. So first we will draw a diagram of the inclined surface. This question is very simple. So first what you need to draw? You need to draw a diagram of this inclined surface. Draw the diagram of the inclined plane. So Ali is here. Ali is sliding down this banister. And after that what you need to do is, after that you mark this angle 35 degree. So 35 degree is the angle. Then after drawing this inclined surface, you need to draw 4 arrows. Number 1 like this. Number 2 just opposite like this. Number 3, number 4. So draw these 4 lines. What is this line? This represents normal force, right? Fn for normal force. This will be always mg sine theta. And this will be always mg cos theta, and this is force of friction. So if you draw this is the basic of inclined plane. So to solve any problem in inclined plane, draw this. What do you want to calculate? You want to calculate the normal force. So normal force will be always equal to mg cos theta. This normal force and mg cos theta will be always equal and opposite. On an inclined plane, the normal force will be always equal to mg cos theta. They will be in the opposite direction. So normal force will be always equal to mg cos theta, which equals, mass is given, right? How much is the mass? 43 kilogram. 43 multiplied, what's the value of g? 9.8 is the value of g. Cos, what is the angle here? 35 degree. So solving the problems in inclined plane is very easy if you draw this. What to draw? First to draw an inclined surface, inclined plane, then mark the angle here, label the angle, how much is the angle given in the question. Then just to draw a dot there, a small circle, then draw 4 arrows from there like this. So this is normal force, and opposite to normal force mg cos theta. This is mg sin theta. Opposite to that is force of friction. Now we will calculate this 43 multiplied 9.8 multiplied cos 35. So make sure when you do the calculation, your calculator must be in degree mode. So if it is in degree mode, it will show D here, it will display D here. That you need to check. So I am getting an answer of 345.2. 345.2 Newton is the value of the normal force. So this is the answer for question number 9. With question number 9, I want to add one more point. If the question is to calculate normal force, so we will write two equations for normal force. First one is normal force is equal to mg for a horizontal surface. If an object is on a horizontal surface, then the normal force is equal to mg. So if the object is on a horizontal surface. So in the topic of friction and inclined plane, you will be calculating the normal force, or you will be using the normal force. So one of the equation for normal force is equal to mg for a horizontal surface. If the surface is on a if the object is on a flat surface, if the object is on a horizontal surface, horizontal surface means flat surface. So if the object is on a horizontal surface, the normal force is equal to mg. Second one, if the object is on an inclined surface, the normal force equal to mg cos theta. If the object is on an inclined surface. So if the object is on an inclined surface, normal force is equal to mg cos theta. Question number 10 is about horizontal projectile motion. Figure 3 in page number 142 of your textbook. So we need to explain that the image, the figure given in that page number. So in a horizontal projectile motion, we will draw the path of the horizontal projectile motion like this. So here this represents the ground, and here you are on top of a building or on top of a hill. So you are here and you are throwing a stone or a ball in the horizontal direction. So you are throwing the ball like this. From here you are throwing the ball. So you are throwing it in a horizontal direction. Okay, you are giving only the horizontal velocity. You are not throwing at an angle. You are throwing like this. So like this you are throwing, not like this. If you throw like this, this is called angular projectile motion. And if you throw like this, here you can see the initial velocity is along the horizontal direction. So this is the horizontal projectile motion. So what will be the path of this object? The object will follow a path like this. It follows a curved path. So here you can see this object was initially here. So now it is traveling a horizontal displacement, right? So it has a vertical displacement, right? The object was here. Now it is at the ground. So it is traveling a height. A height means vertical displacement. The object means the projectile, the ball you have thrown, which has a vertical motion. And the object was here, right? It was the position at the beginning. You can see here the object is moving along the horizontal direction also. The object reached here, right? This is the final position of the ball. So this you can see here, it has a vertical displacement delta y, and it has a horizontal displacement delta x, which means this projectile has a horizontal motion and a vertical motion. So we will explain the properties of horizontal motion and vertical motion separately. So here we will make a table of two columns. So here we will write the horizontal motion of the projectile, and here we will write the vertical motion of the projectile. So you are throwing the projectile, right? You are throwing. When you throw, you are applying a force. After the object is released from your hand, you are not applying the force. So after you release, after the object is released from your hand, after this marker is released from my hand, then the force, I applied a force, but after it released, the force is not acting. The force is acting at the time when I throw. That is a contact force, right? So if there is contact force, when my hand is in contact with the object, I am applying the force. After the object is released from the hand, that applied force is not there, then only one force is acting. After the object is released from your hand, only one force is acting on that object, that is force of gravity. In which direction force of gravity is acting? Force of gravity is acting vertically downwards. Force of gravity is acting in the vertical direction, in the y direction. So in the horizontal direction, no force is acting on the object. Then you may ask, you are applying a force while throwing. That you applied while throwing. After that, after the object is released from your hand, no force is acting along the horizontal direction. Only one force is acting on the projectile if we ignore the air resistance. Only one force is acting on the projectile. What is that force? Force of gravity. What is the direction of that force? Vertically downwards. So on the x-axis or on the horizontal axis, there is no force acting. So there is no force acting along the x direction. So we will write no force is acting along the horizontal direction of the projectile motion. Then what about the vertical direction? In vertical direction, only one force is acting, that is force of gravity. So I will write here, force of gravity is acting vertically downward. Gravity is acting in vertically downward direction. Gravity is acting downward. Then second, if there is no force acting, what about the acceleration here? Acceleration along the horizontal direction. What will be the acceleration along the horizontal direction? If there is no force acting in the horizontal direction, no force means no acceleration. No force means no acceleration. So we will write acceleration is equal to 0, or we will write no acceleration. If there is no force acting, acceleration will be 0. And here you can see, what about the acceleration in the vertical direction? Acceleration along the y-axis. Here a downward force is acting, right? So there will be a downward acceleration. Direction of acceleration will be always along the direction of the net force. So here force is acting downward, so acceleration will be downward. So downward acceleration we will represent minus. Why? We are taking the upward direction positive and downward direction negative in projectile motion. So what this force is force of gravity, and what is the acceleration caused by force of gravity? The value of the acceleration produced by force of gravity is 9.8 meter per second squared. So negative 9.8 meter per second squared is the acceleration along the vertical direction. So if acceleration is 0, what about the Vx? Means velocity along the horizontal direction. Velocity along the horizontal, if acceleration is 0, the horizontal velocity will be constant. So we will write horizontal velocity Vx is constant. Then what about here? What about Vy? The velocity along the vertical direction, when it is falling, you can see when the object is falling, what happens to its velocity? When you throw like this, it has only horizontal velocity. Its vertical velocity is 0. Its vertical initial velocity is 0. After you throw the object, after you release the object from your hand, the force of gravity is acting. Because of the force of gravity, it will have a vertical velocity, and that vertical velocity will be increasing. Why the vertical velocity is increasing? Because force of gravity is continuously acting. If a force is acting, there will be acceleration, then there will be an increase in velocity. So Vy, the vertical velocity, will be increasing. It will be keep on increasing. Why the vertical velocity is increasing? Because force of gravity is keep on acting on that object. And we can represent the velocity using the vectors, okay, velocity vectors. So here initially it has only horizontal velocity. vertical velocity is 0. So this line is must be in the horizontal direction. So initially the object has only the horizontal velocity, and the value of that horizontal velocity will be constant throughout the motion. So when the object reach here, I will draw some positions, okay, of the object. Okay. So here when the object reach here, its horizontal velocity will be same, right? Because horizontal velocity is not changing. So the length of the arrow must be same. When you draw, the length of the arrow must be same, must be equal. Why? Because the horizontal velocity is constant and the length of the arrow represents the magnitude of the velocity. So initially here we are discussing about the vertical velocity of this object. So when you are throwing it horizontally, so its vertical velocity is 0. So here we are not drawing any line for vertical velocity. So then after you throw, vertical velocity will start, it will have a vertical velocity. Why? Because of force of gravity. Then I will draw a small line here to represent vertical velocity, and when it is falling, okay, while it is falling, we know that the vertical velocity is increasing, right? Why the vertical velocity is increasing? Because force of gravity is continuously acting on the object. So when it is reaching here, vertical velocity will again increase. So this one we will represent by Vy. Question number 11 is from horizontal projectile motion. Example 1 and question 1 from page number 144 of your textbook. So you are preparing breakfast and slide a plate on the countertop. Unfortunately, you slide it too fast, so it flies off the end of the countertop. So what are you doing? You are sliding a plate on the countertop, so you are sliding it too fast, so the plate flies off the countertop. So this is a question from projectile motion. So to solve any projectile motion question, you can follow this method that we are going to discuss here. If you follow this method, it will be very easy for you to solve any question from projectile motion. So this method will simplify your task. So what you need to do is you make a table of 2 columns. Why a table of 2 columns? Because projectile has horizontal motion and vertical motion. So here we will write the horizontal motion of the projectile. I will write HM, H for horizontal and M for motion. So here vertical motion. Then in horizontal motion we will write Vx, that is the velocity along the x direction. X direction is the horizontal direction, and the displacement along the horizontal direction, the distance traveled, delta x, and time. And here in vertical motion we will write the initial velocity, final velocity, acceleration, displacement, that is vertical displacement we will represent by delta y, and time. Then now we will read the question. So when you read the question, you need to write what is given in this question. If the countertop is 1.05 meter above the floor, so what is given here? The height of the countertop is given, right? Height of the countertop, which means the vertical height. Height is always vertical displacement. What is the height of the countertop? That is 1.05 meter. So delta y is 1.05 meter, and initial vertical velocity will be always 0. Acceleration will be always negative 9.8 meter per second squared in projectile motion. Then what else is given? If the countertop is 1.05 meter above the floor and it leaves the top at 0.74 meter per second. So its initial velocity, it is moving in a horizontal direction like this. So initial velocity will be the horizontal velocity, that is given 0.74. 0.74 meter per second, that is the value of the velocity along the horizontal direction. Means when the plate flies off the countertop, it will have only the horizontal velocity, right? Its vertical velocity will be 0. That's why we wrote vertical initial velocity is 0. And how far from the end of the countertop does it land? So you need to calculate the displacement. You need to calculate the horizontal distance traveled. How far it traveled. How far means the horizontal distance traveled. So in the question, if they have given how far, in a projectile motion question, how far, which means delta x, you need to calculate the horizontal distance traveled. So to calculate horizontal distance traveled, you have only one equation, the equation in horizontal direction. What is that? You have only one equation here. To calculate horizontal direction, you have this equation, delta x, that is equal to horizontal velocity into time. So this is the only equation that you can use to calculate the horizontal distance traveled in projectile motion. So here to calculate this, you need Vx is given here, and you need time also, but time is not given. And if time is not given, what you need to do is you need to calculate time from here. From the vertical motion, you need to calculate time. So in vertical motion, you have three equations. Number one, the first equation is, see, for projectile motion, there is no separate equation. For projectile motion, you will be always using the equations of motion. So the first equation is final velocity, that is equal to initial velocity plus acceleration into time. So out of this, you can see here, see there are five, right? Five data is here: initial velocity, final velocity, acceleration, delta y, time. So out of these five, what is not there? Here in the equation there will be only 4. So which one is missing here? Here final velocity is there, initial velocity is there, acceleration is there, time is there. So delta y is missing. So you will be using this equation if there is no delta y. If no delta y, you will use the first equation. Then second equation, that is delta y, means vertical displacement, which is equal to initial velocity into time plus half multiplied acceleration multiplied time squared. In this you can see Vf, that is the final velocity, is missing. So when there is no final velocity given in the question, you will use that equation. Equation number 1, equation number 2. Then equation number 3, that is these are equations from equations of motion, right? There is no separate equation for projectile motion. We will be using the equations of motion to solve any question from projectile motion. So final velocity squared, that is equal to initial velocity squared plus 2 multiplied acceleration multiplied delta y. This is the third equation. You can see in this equation time is not given. So if there is no time given in the equation, no time, okay, it's not no time. If there is no time given in the question, we will be using the equation number 3 to solve our numerical problems. So here first you need to calculate time, right? So we have we have initial velocity, final velocity is not there, so we cannot use this equation. So to calculate time, we will use the second equation, okay, because to calculate time, here we have initial velocity and here we have height and we have the value of acceleration. So if final velocity is not given, right, we need to calculate a time here. So time, I will put question mark, final velocity is no final velocity, then we will use the second equation to calculate time. So I will write the second equation like this: delta y, which equals initial velocity into time plus half multiplied acceleration multiplied time squared. So here initial velocity will be always 0 in a horizontal projectile motion. So the equation become like this: delta y that equals this initial velocity is 0, so that term becomes 0, half multiplied acceleration multiplied time squared. You need to calculate a time, right? So when I rewrite this equation for time, it becomes like this: square root of 2 multiplied delta y divided by acceleration. So what you need to do, if displacement is given, means if the height is given, and the question is to calculate a time, or you have to calculate a time, then directly use this equation. T is equal to square root of 2 multiplied height divided by acceleration. So it becomes like this, which equals square root of 2 multiplied the height. Well, how much is the height? Height is 1.05 meter. 1.05 meter divided by acceleration. The value of acceleration is negative 9.8, right? So here height will be like the vertical displacement. The plate is moving down, right? So it is having a vertical displacement in the downward direction. So this height will be also negative, okay? And this negative will be cancelled from the numerator, and this negative will be cancelled. So no need to write that. And whenever you calculate time will be always positive. There is no negative time. So when you get the answer, when you get to time, it must be in a positive value. So 2 multiplied 1.05 equals divided by 9.8 equals, and square root of our answer, which equals 0.46. So the time taken is 0.46 second is the time taken. I will just do the calculation one more time. Square root of 2 multiplied 1.05 divided by 9.8, which equals, yes, our answer is correct, 0.46 second is the value of the time taken, the value of the time. So we got the time, right? Now we got the time. How much is the time? 0.46 second is the time taken. So now I know the time. So to calculate the how far, means the horizontal distance traveled, I will use this equation. Horizontal velocity, that is 0.74, multiply the time we calculated, 0.46, which equals 0.74 multiplied 0.46 equals 0.34 meter is the horizontal distance traveled by the plate. The second question, in question number 11, you throw a stone horizontally at a speed of 5 meters per second from the top of a cliff. So this is a question from horizontal projectile motion. So in any projectile motion, projectile has both horizontal motion and vertical motion, and we have these equations, means we do not have separate equations for projectile motion. In projectile motion, we use equations of motion. So here, for the horizontal motion, we have one equation, that is horizontal displacement delta x, that equal to velocity along the horizontal direction multiplied the time taken, means the distance traveled is equal to velocity into time. Then in the vertical motion, we have three equations, means we have three equations of motion, right? That is, first one is final velocity equal to initial velocity plus acceleration into time. We will use this equation if delta y, means the height, is not given in the question. Then second is delta y, that is the height, is equal to initial velocity into time plus half multiplied acceleration multiplied time squared. You can see in this equation final velocity is not there, so we will use this equation when final velocity is not given in the question. Then third equation is final velocity squared, that is equal to initial velocity squared plus 2 multiplied acceleration multiplied delta y. In this equation you can see time is not there, so we will use this equation when time is not given in the question. So I just wrote no time, no final velocity, delta y. So you throw a stone horizontally at a speed of 5 meter per second from the top of a cliff. So here you are here from the top of cliff, you are throwing a stone in the horizontal direction. So you are throwing like this, okay, your in the direction of initial velocity is like this. So the object will follow a path like this, right? The stone will follow a curved path. That is the trajectory of a projectile. So it is following a curved path. So here, what is the velocity? This velocity, that is 5 meter per second, means the velocity you are throwing, that is 5 meter per second, that is given in the question. So here it is given, you throw a stone horizontally at a speed of 5 meter per second from the top of a cliff, that is 78.4 meter is the height. So the height of the cliff is 78.4 meter. This is the height of the cliff. So this is the sketch and analyze the question, right? Whenever you solve a question, the first step is we need to sketch and analyze the question. So drawing, and what is the meaning of analyzing the question? Analyzing question means we are writing what is given in the question. So in projectile motion, we know that a projectile has both horizontal motion and vertical motion. So I will write here horizontal motion and vertical motion. So in horizontal motion, we need three things, that is delta x, and I will write vx first, horizontal velocity, horizontal distance traveled, and time. So in this, what is given in the question? Only the horizontal velocity is given, 5 meter per second is given. Other two things are not given in the question. Then in final velocity, we have 5 things. Initial velocity means, sorry, in vertical motion we have 5 things. Initial velocity, final velocity, displacement, acceleration, and time. So what else is given? We know that it is a horizontal projectile motion, right? In a horizontal projectile motion, vertical initial velocity will be always 0, because you are throwing like this, right? You are throwing in the horizontal direction, so you are giving initial velocity only in the horizontal direction. So its initial velocity along the vertical direction will be 0. So what is the final velocity? Final velocity is not given in the question. So final velocity is not given. And delta y means the height. The height is given, it is equal to 78.4 meter, and acceleration will be always 9.8 meter per second squared, negative 9.8 meter per second squared. That will be the value of acceleration in a projectile motion, and time is not given. So here we have 3 questions. Okay, question A states, how long does it take the stone to reach the bottom of the cliff? We need to calculate the time. So how long does it take to reach the bottom of the cliff? So to calculate time, you can see here, we have horizontal motion and vertical motion. To calculate time, you can calculate time either by using horizontal motion and vertical motion. But in this question, you cannot use this horizontal motion equation. What is the horizontal motion equation? Delta x equal to Vx into t. Why? Because to calculate time, we need to know Vx and delta x, means the horizontal distance traveled. The horizontal distance traveled is not given in the question. That's why we cannot use this equation. If anything is given here, like for example, here we have 3 data, right? Out of these 3, if 2 is given, then you can use this equation to find the third. Here, out of the 3, only 1 is given. That is why you cannot use this horizontal motion equation to calculate any of this. So we have vertical motion equation, and we are asked to calculate the time, right? We need to calculate the time first using the so what we will use is, we will use the vertical motion equation. So here you can see initial velocity is 0, final velocity not given in the question, and we have The height is 78.4 meter, acceleration negative 9.8. So here you know that here final velocity is not given. So if final velocity is not given, which equation will you use? You will use an equation that in that equation final velocity is not there. So we will use the second equation, that is delta y, which means height is equal to initial velocity into time plus half multiplied acceleration multiplied time squared. So you need to calculate time. So here delta y, the value is given, and the initial velocity is 0, right? As initial velocity is 0, this term velocity into time, so velocity along the vertical direction. So here we are using this vertical motion here, okay, vertical motion. So in vertical motion you can see initial velocity is 0, so this term will be cancelled, right, because it becomes 0. Then if you rewrite the equation to calculate t, time is equal to, the equation become like this, square root 2 multiplied delta y divided by acceleration, so which equals square root 2 multiplied the value of delta 8 is delta y is 78.4 meter divided by acceleration is 9.8. So when we do the calculation, square root 2 multiplied 78.4 divided by acceleration, the value of acceleration is 9.8. So I will get 4. I am getting 4 seconds. 4 seconds. So here this negative 9.8, right? So you may think that why I didn't write a negative. And you can see this one, this object is falling, actually it is moving in the downward direction, right? So displacement is downward direction. The height, see the height 78.4 meter, but what the stone is moving, in which direction the stone is moving? Stone is moving like this, right? So it is actually moving down. It is having a 78.4 meter displacement in the downward direction. So this displacement will be also negative. Why negative? Because displacement is in the downward direction. So this negative sign and this negative sign will be cancelled. That is why I didn't write it. So here the time taken by the stone to reach the ground is 4 seconds. So what is the easiest method to calculate time? If the height is given, remember, if the height is given, you can use this equation to calculate time. This is not a separate equation. You may think that how many, like there are many equations. No, there are not many equations. There are only 3 equations. 1, 2, 3 equation. So what about this equation? This equation is when acceleration is 0. If the acceleration is 0, this equation, the second equation become like acceleration is 0, right? So this term is 0. What about this equation? This equation to calculate time when height is given, that we are rewriting the second equation, okay? Second equation we are rewriting and make it a simple equation to calculate time. So if the question is to calculate time and the height is given, just directly use, you can directly use this equation instead of wasting your time by writing these equations and simplifying and doing things. Then question B, how far from the base of the cliff does the stone hit the ground? So we calculated time, right? So I will write the time here. Time we calculated and we got 4 seconds. See, time is common. Time is common in the horizontal motion and vertical motion. So time will be equal in the horizontal motion and vertical motion. This time also will be 4 seconds. Time is common, okay? Because this stone is traveling this much height and this horizontal distance in the same time. The same time the stone is traveling the horizontal distance and vertical motion. It is not traveling separately. It is traveling at the same time. It's traveling simultaneously. So the time is same for the horizontal motion and vertical motion. And now we need to calculate how far that stone traveled. How far means, it always means the horizontal distance traveled. that is delta x. How far means delta x. So you need to calculate the delta x, the distance traveled by the stone while when it reach the ground. So this distance, right, from here you are throwing, so the distance traveled, this distance you need to calculate from the point of throwing to the point of the stone reaching. So here question B, we need to calculate what? The horizontal distance. To calculate the horizontal distance, we have only one equation. See, delta x, that is equal to Vx, means horizontal velocity multiplied time. So delta x equals, what is the value of Vx? Means the velocity along the x-axis, velocity along the horizontal direction, that is given in the question 5 meter per second multiplied the time you calculated and you got 4 seconds. So 5 into 4, it will be 20. So 20 meter is the distance traveled. Then question C, what are the horizontal and vertical components of stone velocity just before it hits the ground? So we need to calculate the horizontal and vertical component of the velocity. So I will just erase these things. To get some space here so that I can write. So here, when the stone reach the ground, initially when you throw, you are giving only the horizontal velocity and its vertical velocity is 0. But after you release the ball, release the stone from your hand, because of gravity, its vertical velocity will be increasing. Means after you just throw, it will have a vertical velocity, and when it is falling, its vertical velocity will be increasing. Vertical velocity will be increasing. Why increasing? Because force of gravity is keep on acting. So vertical velocity is keep on increasing because of the force of gravity. Then the stone will always have a horizontal velocity also. The horizontal velocity will be constant throughout the motion. So when you are throwing the ball, it has a horizontal velocity that we will draw by using this arrow. So this horizontal velocity will be constant throughout the motion. So I am trying to draw the arrow with the same length. Horizontal velocity is constant throughout the motion. So what is this? This is vertical velocity Vy, vertical velocity, and horizontal velocity. Horizontal velocity constant throughout the motion. So here in question C, what you need to do is you need to calculate the component of the stone's velocity just before it hits the ground. Just before it hits the ground, it has horizontal velocity and vertical velocity, and we need to calculate the means the value of this horizontal and vertical velocity. So just before it hits the ground, what will be the value of the horizontal velocity? Means the velocity along the x-axis. What will be the value? We have discussing the horizontal velocity is constant throughout the motion, right? So the value of horizontal velocity just before it hits the ground will be 5 meter per second, because it will not change. Then vertical velocity, that is not given anywhere in the question, so you need to calculate. What is the equation to calculate vertical final velocity? You can calculate vertical final velocity using this equation. Final velocity, that is equal to initial velocity plus acceleration multiplied time. What is the value of the final velocities? That is what we need to calculate. So initial velocity along the vertical direction, that is 0, right? What about the acceleration? Acceleration is always negative 9.8, and time you calculated and you got 4 seconds. So 9.8 multiplied 4. 9.8 multiplied 4, which equals 39.2. Negative 39.2 meter per second is the value of the vertical velocity. What does this negative sign represent? Negative sign represents the direction of vertical velocity is downward. That you know that, right? From the diagram, vertical velocity is acting in the downward direction. Then next is, so I will just write the answers here. Vx, the horizontal component of the velocity, that is 5 meter per second, and the vertical component of the velocity Vy, that is equal to 39.2 meter per second. Negative, right? Negative just represent the direction. Then what about the resultant velocity? That is not in the question, but I am just adding this. How to calculate the final velocity here means the resultant of the x component and y component. You can see here this x component and y component are perpendicular, right? If two vectors are perpendicular or two velocities are perpendicular, how to calculate the resultant velocity? You know that to calculate the resultant velocity we use Pythagorean theorem. So I will just write final vertical velocity. So final velocity, okay, I will just write final velocity, just we will write v, that is the resultant velocity, that is equal to square root of vx squared plus vy squared, which equals square root of, what is the value of vx? 5, right? 5 squared plus negative 39.2 squared equals square root of 5 squared plus 39.2 squared, 39.5. So 39.5 meter per second is the value of the value of what? Value of the velocity or value of the resultant velocity just before the stone hit the ground. Then what about this angle? How will you calculate the angle? This angle made by the resultant. So this is the resultant vector v, right? Resultant velocity. So angle made by the resultant velocity from the x-axis, that is the theta represent, that is the direction, right? So how to calculate the angle? To calculate the angle, you always have this equation, tan inverse y by x. Tan inverse y by x. What is on y-axis, or the value of the y component divided by the value of the x component. So tan inverse, what is on the y side? Y means this side, right? Okay, this side will be equal to this side, that is vy. Vy is how much? 39.2. So tan inverse 39.2 over vx. Vx is this value, right? 5. Means the value of the y component divided by the value of the x component. So shift tan, so we get a tan inverse 39.2 over 5 equals 82.7 degree. So I am just checking whether my calculator in degree mode. Yes, it is in degree mode. So how much? 82.7 82.7 degree from the x-axis. So this resultant velocity makes an angle 82.7 degree from the x-axis. Question number 12, types of force, system and agent, from page number 85. And an image of forces acting on a book is given in page number 85. So what are the two types of force? We are studying about two types of force. So I will just write force here. Force we divide into two types. One is called contact force, and another force is the non-contact force. Non-contact force. This non-contact force has another one more name, that is field force. Field force. So what is the meaning of this? What is the meaning of contact force and non-contact force? Contact force means to apply that force there must be a contact between system and agent. System and agent. So first we have to know what is system and what is agent. So system and agent. So here, for example, this bottle. So I am lifting this bottle. I am lifting the bottle. So what object is experiencing the force? The bottle is experiencing the force. Oh, I am pushing the bottle. So what is experiencing the force? The bottle is experiencing the force. The object experiencing the force is called system, and the object or the person that is exerting the force, applying the force, is called the agent. So here you can see my hand is applying the force. So my hand is the agent. The hand is the agent, and what is experiencing the force? The bottle is experiencing the force. So the bottle is the system. So system means the object which is experiencing the force. System is the object experiencing the force. Object experiencing the force, and agent is the object or the mean that is the cause, right? The cause of the force, the person or the object that is applying the force. Applying the force. So what are the examples of contact force? You are pushing a table, it's a contact force. So I am just pushing this wall, contact force, because to apply that force my hand must be in contact with the object. So I am taking this calculator, it's a contact force. You are opening the door, contact force. So like pressing the switch to turn on the light or to turn off the light, it's a contact force. So all those forces are example of contact force. And frictional force, to apply friction there must be contact between two surfaces, it's a contact force. So the force we are generally applying is a contact force, right? So another example is force of friction is a contact force. The normal force, for example, you are sitting on a chair while watching this video. So what the chair is doing, the chair is pushing you up. The chair will push you upward. Why chair is pushing up? Because you are pushing the chair downward. So the chair is pushing you up, means chair is applying an upward force on you. That is the normal force. Normal force is an example of contact force. Normal force. So what are the examples for field force or non-contact force? You know the magnet, right? So two magnet will exert a force on each other without in contact. You can move a nail, or you can attract a nail using a magnet without touching the nail. So magnetic force is a non-contact force. Magnetic force. So these are examples, okay? Examples. Magnetic force is an example of non-contact force, field force, magnetic field. Then another example, you know that force of gravity. For example, this object, this marker is falling down because of gravity. The object, the marker, is not in contact with earth, still the gravity is acting. So it is an example of non-contact force, force of gravity, the field force, force of gravity. That is an example of non-contact force. Next, this is a table here, a table. and on this table we will keep this water bottle. We will keep this water bottle like this on the table. So here I will draw a water bottle. Okay, very good in drawing. So on this water bottle, two forces will be acting. On every object, two forces will be always acting. In free fall also two forces acting, force of gravity and the air resistance. So here two forces will be always acting on every object. So number one is the force of gravity that will be acting vertically downwards. Force of gravity that is acting vertically downwards. So force of gravity we write like this. We will represent the force by the letter F. We represent force by the letter F. Then we write a subscript. What does the subscript represent? Subscript always represent agent on system. Agent on system. For example, so this force of gravity, what applies this force of gravity? The force of gravity is applied by earth, right? Earth. So I will write here earth. The name of the agent, earth. Earth is applying this force of gravity on the system. On what? On what? Which object the earth is applying that force of gravity? Earth is applying on bottle. So we need to write the force, so we need to represent the force like this by writing agent on system. So this is how we write the force completely. Then the second force acting on this water bottle, that is the upward force, that is the normal force. How? Because the table will push the water bottle up. So that force we will represent by F. Then we will write the agent. This force is applied by what? Applied by table, right? This force is applied by table. So name of the agent is table. On what? Table on the system. System is bottle. So here you can say both these forces, the two forces are acting on the bottle, right? The system is on the bottle. These two forces are acting on the bottle. Means the two forces, these two forces, the force of gravity and normal contact force are acting on the same object. What is that same object? The bottle, right? So these two forces are acting on a single object. So these two forces are not example for interaction pair. Why? Because interaction pair, the action and reaction, they act on two different objects. So this is not an example for interaction pair. These are the forces acting on a single object. When a bottle is kept on the table, two forces will be acting. Force of gravity is acting and the normal contact force is acting. So in this question our topic is the type of force. We have two types of force, right? Contact force and non-contact force. In this, out of these two forces, which one is non-contact force? This force of gravity, right? Force of gravity is an example of non-contact force. It is also called field force. And this force, the normal force, because the table is pushing the bottle up, right? That is an example of contact force. To exert that force, the bottle must be in contact with the table. If the bottle is not touching the table, then normal force will not be acting. Then in that page, another example given is, for example, a book is hanging like this. So instead of book, I will use this table, this water bottle as an example. So what is happening? Okay, A water bottle is hanging like this. So now also two forces are acting on this water bottle. One is force of gravity is acting downward. How to represent that? F earth, applied by earth, right? F earth on the bottle. Another force, the upward force acting, is the tension in the string. The tension in the string. So if I draw a free body diagram, that will be like this. So here is our bottle. Then one force is acting, force of gravity is acting, F, applied by what? Earth, agent, on what? Bottle, the system. Then second is the upward force, F. Here that is the tension, right? Applied by what? What is the agent? The string is the agent. String. On which object the force is acting? Bottle, right? Bottle is experiencing the force. So this is the agent and this is the system, right? Okay. So when you write the force, you don't have to write this is agent and system. Okay. So this is the correct method of writing this much. Then next, the third example given is if the book is falling, like so here we will take the bottle is falling, the force acting on the bottle is force of gravity. That is an example of non-contact force, force of gravity. So here also this is a non-contact force and this is a contact force. Question number 13, circular motion relationship between centripetal acceleration, speed and radius. From page number 149 of your textbook. So in this question we are discussing about circular motion. So that is question number 13, circular motion. An object is moving along a circular path. So here we will draw an object that is moving along a circular path. So for example, here we have an object. So this object is moving along the circular path. When this object complete one full rotation, the object is starting from this point and it is moving along the circular path in the anti-clockwise direction and completing the one circular path, completing the one rotation. So what is the distance traveled? When an object complete one rotation along a circular path, the distance traveled, that is equal to circumference of the circle. For example, the radius of the circle is r. R is the radius of the circle. So its circumference, that is equal to 2 pi r. That is the equation for circumference of a circle. So the distance traveled when an object to complete one full rotation, that is equal to 2 pi r. And the time it takes, the object takes to complete one rotation, that is called time period. Time period. So what is the meaning of time period? Time period is the time taken to complete one rotation along this circular path, that is called time period. So what is the speed? How to calculate the speed of this object when it is moving along a circular path? How to calculate the speed of an object that is moving along a circular path? So the speed of the object is equal to, what is the basic equation to calculate speed of any object? Speed is equal to distance divided by time, right? Distance traveled divided by time taken to travel that distance, that is the speed. So speed we will represent by the letter V. Speed we are representing by this letter V. Speed is equal to, when an object to complete one full rotation, the distance traveled is 2 pi r divided by the time taken to complete one full rotation, that is equal to time period t. So the speed of circular motion or speed of an object moving along a circular path can be calculated using this equation if you know the value of the radius of the path and time period. Time period means time taken to complete one full rotation. So this is our equation number 1 in circular motion, that is to calculate the speed of an object. Then second is, you can see here, when the object is moving along the circular path, at this point, this is the direction of the speed of the object. When this object reach here, sorry, direction of the velocity, right? Velocity is a vector quantity, it has direction. So here, when the object is moving along the circular path and when the object reach here, the direction of its velocity at this point is like this. When the object reach here, the direction of velocity is like this. Draw a tangent, right? So when the object reach here, the direction of velocity is like this. The direction of velocity is given by the tangent at that point. So direction of velocity of an object moving along a circular path is given by the tangent drawn at that point. So here you can see the direction of velocity is continuously changing. If the direction is changing, which means velocity is changing. Velocity changing means the object is accelerating. See here, what we said, when an object is moving along a circular path, the object is continuously accelerating. Why the object is accelerating? Even if it is moving at a constant speed, the object is accelerating. Why? Because the direction of motion is continuously changing. The direction of motion is continuously changing for an object that is moving along a circular path. So which means the object is continuously accelerating. That acceleration we will represent by A. We use the letter A to represent the acceleration and C to represent centripetal acceleration. The acceleration of an object moving along a circular path is called centripetal acceleration. What? Centripetal acceleration. Centripetal acceleration we will represent by A and as subscript C. C for centripetal. So the centripetal acceleration is given by the equation speed squared divided by radius. So this is the equation to calculate the centripetal acceleration, and this is our equation number 2 in circular motion. Equation number 2 in circular motion, to calculate the centripetal acceleration, we have this equation, v squared over r. What is v? V is the speed of the object, and what is r? R is the radius of the object. Then if there is an acceleration, you know that you have studied in Newton's second law, if there is an acceleration, there must be a net force. So the object moving along a circular path is continuously accelerating, which means if an object is moving along a circular path, there is a net force is acting on the object, and that net force is called centripetal force. So what is centripetal force? Centripetal force is the net force acting on an object that is moving along a circular path. So centripetal force that we will represent by F for force and C for centripetal. So Fc, that is given by the equation. We know that a net force is always mass multiplied acceleration. So centripetal force is mass multiplied centripetal acceleration. What did I say? According to Newton's second law, the net force is always equal to F is equal to ma, right? Mass multiplied acceleration. In circular motion, the centripetal force is the net force that is equal to mass multiplied centripetal acceleration. So we will write the centripetal force is equal to mass multiplied centripetal acceleration. So here centripetal force, which is equal to mass multiplied, what is centripetal acceleration? Centripetal acceleration is v squared over r. From this equation number 2, v squared divided by r. So this is the equation to calculate the centripetal force that is the net force acting on an object moving along a circular path. And this equation I will write, this is our third equation in circular motion. So in circular motion we have now three equations. One equation is to calculate the speed of the object, that is 2 pi r divided by t, where r is the radius and t is the time period. Second equation is for centripetal acceleration. Centripetal acceleration is v squared over r, and we know that if an object is moving along a circular path which is continuously accelerating, why? Because the direction of velocity is changing. Then the third equation, that is to calculate the centripetal force. Centripetal force is the net force acting on an object moving along a circular path. So force will have a direction, right? Force is a vector quantity which has a direction. So what is the direction of the force, or direction of the centripetal force acting on an object? The direction of centripetal force is always towards the center of the circular path. Centripetal force at every point, at any point, if an object is here, then what is the direction of the centripetal force acting on that object? That is towards the center. So centripetal force is always directed towards the center of the circular path. What about the direction of centripetal acceleration? Direction of acceleration will be always along the direction of the force. So the direction of centripetal force and centripetal acceleration will be towards the center of the circular path. What is the direction of centripetal force and centripetal acceleration? Towards the center of the circular path. The object is moving like this. So centripetal force is towards the center of the circular path. Question 14. That is a question from page number 152 of your textbook. You are sitting in the back seat of a car going around a curve to the right side. Sketch the motion and free body diagram to answer this question. Question number A. What is the direction of acceleration? Direction of acceleration will be always towards the center of the circular path. What is the direction of the net force acting on you? That will be also towards the center of the circular path. What exerts this force? You are sitting on the back seat of a car. So centripetal force will be exerted by the seat of the car. So the force is exerted by the seat. Question number 15, that is from the vector addition. We have three vectors here. That is, for example, three forces. One vector that is given as vector k, and its value is 4. Negative 4, given negative sign is to represent the direction, and another vector that is along this side, and its value is given as 6. And another vector, the third vector, that is along this direction, and its value is 5, and which makes an angle 37 degree. So how to calculate the resultant of these three forces? So to calculate the resultant, first we will calculate the resultant of these two, 4 and 6. So 4 and 6 they are in the opposite direction. So to find the resultant of, or sum of, these two forces, okay, this one and the second one, 4 and 6, they are in the opposite direction. So subtract 6 minus 4. 6 minus 4 is equal to 2. So 2 will be along this direction. So its value is 2, because this is the resultant of this 6 and 4, and we have another force that is along this direction, that is its value is 5, which makes an angle 37 degree with the horizontal, with the x-axis. Now we need to calculate the resultant here. So what we will do is, this is a 2, and this one we will divide into two components, the x component and the y component. So its x component will be 5 multiplied cos 37, 5 multiplied cos 37, and its y component will be 5 multiplied sine 37. Means that is the resolution of vector. We are dividing vector using the trigonometry, sine and cos. So what we did, this one, the 2, I wrote it as 2, and this one, the 5, that is not along the x direction, not along the y direction, that is acting in between x and y. So we can divide that into or we can split that into the x component and the y component. X component, we discussed, it is always cos theta, and y component will be always sin theta component. So I will write this 5 multiplied cos 37 which equals 3.99. so I will write 4 here. So this value, that is equal to 4, and 5 multiplied sine, right, sine 37, right, sine 37 which equals 3. So this is equal to 3. So we got like this. This side we have this 2 plus 4, so this side we have 6, and this side we have 3. So now we have, for example, if these are forces, we have two forces, right? One is to the right side and other is to the north side. So east and north. So what will be the resultant? So here the angle is 90 degree, right? This angle is 90 degree. If two forces are acting at an angle 90 degree, to calculate the resultant, you can use the Pythagorean theorem. So I will write here the resultant of these forces, that is equal to square root of 3 squared plus what, 6 squared, equals 3 squared plus 6 squared, how much? 3 square root of 3 squared plus 6 squared, square root of 3 squared plus 6 squared equals 6.7. So 6.7 is the value of the resultant, 6.7 Newton. For example, if this is force, there will be a unit, right, Newton. So 6.7, that is will be along this direction, right? It will be in between this x and y. So if the question is to calculate this angle, how much the resultant makes, resultant r is equal to 6.7, right? How much this resultant makes with the x-axis, to calculate the angle, we will always use tan inverse angle theta, which is equal to tan inverse y by x, which equals tan inverse, what is on y-axis? Y-axis is this side, right? That will be equal to this side 3 divided by 6, tan inverse 3 by 6, which equals shift tan 3 by 6 equals 26.6. So this makes an angle 26.6 degree from the horizontal. The resultant makes an angle 26.6 degree from the horizontal, nothing. So here we have calculated, if there are three forces given, how to calculate the resultant of those three vectors with the help of resolving a vector. So here the third vector is given, which is making an angle with the horizontal. So we need to split that vector into its x component and y component, then add the vectors as usual. If they are in the same direction, add. If the vectors are in the opposite direction, subtract. If it is in perpendicular, means if vectors are acting at an angle 90 degree, use Pythagorean theorem. And to find the angle, use tan inverse y by x. Question number 16. To calculate the centripetal acceleration. So these are the questions from page number 121 of your textbook. In that first question, a runner is moving at a speed of 8.8 meter per second. So speed is given, speed v equal to 8.8 meter per second. So first step is, whenever you read the question, write what is given in the question. A bend with a radius of 25 meter. The radius of the path is given 25 meter. What is the centripetal acceleration of the runner, and what agent exerts the centripetal acceleration? So you need to calculate the centripetal acceleration. To calculate centripetal acceleration, we have this equation, centripetal acceleration, which is equal v square over r. So what's the value of v? 8.8 squared over the radius is 25. So 8.8 squared over 25, 8.8 squared over 25 equals 3.1 and acceleration will be, unit of acceleration is meter per second squared. In that, the second question, a 16-gram ball at the end of a 1.4 meter string is swung in a horizontal circle. It revolves once every 1.09 seconds. So here, what is the mass? Mass is 16. Mass is 16 gram. Mass is 16 gram. And what is the radius? Radius of the string means radius will be equal to length of the string. So radius is equal to 1.4 meter. And what else is given? It revolves once every 1.09 seconds. So time taken to complete one rotation, that is called a time period, that is 1.09 seconds. What is the magnitude of string's tension? The tension in the string. So here tension, that is equal to centripetal force. For example, this object, so we tied it using a string, then we are rotating it in a horizontal circle like this. For example, the object is rotated in a horizontal circle like this. So the radius of the circular path will be equal to length of the string, right? So can you see here, I am holding on the one end of the string, and the radius of the circular path, that is equal to length of the string, right? See, radius, so this is the circular path, right? So its radius is equal to length of the string. And what gives the centripetal force? We said that when an object is moving along a circular path, there must be centripetal force. So here, what is the cause of centripetal force? What provides that centripetal force? Like, are we pushing it in a circular path? Here, what is providing that centripetal force? Here you can see the centripetal force is provided by the string, right? The tension in the string provides the centripetal force for this object to rotate. So here your question is, or you are asked to calculate the tension in the string, right? So this is time period. Tension, we will write F T, that is tension you need to calculate. So how to calculate tension here? Here the tension will be equal to centripetal force. Why? Because here the tension provides the centripetal force. So tension, how to calculate tension? Force of tension, that is equal to centripetal force. So calculate centripetal force, mv squared over r. That is the equation to calculate centripetal force, mv squared over r. So what is mass? Mass is 16 gram. Is gram the SI unit of mass? No. What's the SI unit of mass? Kilogram. So change the mass from gram to kilogram. When you calculate the units, the quantities given must be in SI units. So 16 gram, when you change into kilogram, how to change gram to kilogram? Divide by 1000. So it become 0.016, right? See, like this, 16 divided by 1000. When you divide 16 by 1000, it become 0.016 kilogram. 16 gram is 0.016 kilogram multiplied. V squared is a speed given. Speed is not given. If the speed is not given, first you need to calculate the speed. How to calculate the speed? If radius and time period is given, you can calculate. First you calculate the speed. Okay. First you calculate the speed. So how to calculate speed? Speed is equal to 2 pi r over time period t, 2 pi multiplied r. What is the radius? Radius is 1.4 meter. So 2 pi multiplied 1.4 over time period. How much is the time taken to complete one rotation? 1.09, which equals, so we will calculate the speed and we will use the value of speed here in this equation to get the centripetal force. So 2 multiplied shift pi multiplied 1.4 divided by 1.09, that's the value of the time period. So I'm getting 8.07 second, that is the value of the time period. So we will use that value of the speed of the object. So we will use that value of speed here in this equation, 8.07 squared, right? mv squared divided by radius. How much is the radius? The value of radius is 1.4, which equals 0.016 multiplied 8.07 squared divided by 1.4, which equals 0.744. 0.74 Newton is SI unit for force, right? So this is the value of the centripetal force acting on the object, which means that is the equal to tension in the string, that is equal to tension in the string. Then we will move to the next question. An object swung in a horizontal circle supported by a 1.8 meter string. So 1.8 meter string, right? Just like this 1.8 meter string. So when an object is whirled or moved in this horizontal circle, the radius is equal to length of the string, right? So we got the radius is equal to 1.8 meter. Radius r, that is equal to 1.8 meter. It completes a revolution in 2.2 seconds. It complete a revolution means the time period, the time taken to complete one rotation, that is equal to 2.2 seconds. What is the object centripetal acceleration? You are asked to calculate the object centripetal acceleration. The equation to calculate centripetal acceleration is v squared over r. Centripetal acceleration, that is equal to v squared over r. But the problem is v is not given in the question, so you need to calculate the speed first. V is the speed, right? Centripetal acceleration is v squared over r, where v is the speed, r is the radius. Radius is given here, but speed is not given. How to calculate speed? First you use this equation to calculate speed, then use that value of speed in this equation. So speed is equal to 2 pi r over time period t, that is 2 pi multiplied r. R is 1.8 divided by time period is 2.2. Do the calculation, get the value of speed. 2 multiplied shift pi multiplied 1.8 over 2.2 equals 5.14. So the speed is equal to 5.14 meter per second, that is a unit of speed. We will use that value here, 5.14 squared divided by radius. What is the value of the radius? Radius is 1.8 meter. 1.8, which equals divided by 1.8, 16.7, sorry, 14.7, 14.7 meter per second squared, that is the value of the centripetal acceleration. Then another question, a bowling ball has a mass of 7.3 kilogram. What force must you exert to move it at a speed of 2.5 meter per second around a circle with a radius of 0.75 meter? A bowling ball has a mass of 73 kilograms. So here mass is given in the SI unit 7.3 kilogram, not 73, 7.3 kilogram. So mass is given in SI unit. You do not have to change it because the SI unit of mass is kilogram. What force must you exert to move it at a speed of 2.5 meter per second? Here speed is directly given. 2.5 meter per second is the speed. And what is the object centripetal acceleration? You need to calculate the speed of 2.5 meter per second around a circle with a radius of 0.75 meter. So radius is given as 0.75 meter. And what do you need to calculate? You need to calculate what must you exert. What force you must exert means you need to calculate the centripetal force here. The equation to calculate centripetal force is mv squared over r. So here mass is given 7.3 multiplied v squared, speed is given as 2.5. So 2.5 squared divided by radius is given as 0.75. So all the values are given. Directly use those values in this equation of centripetal force. 7.3 multiplied 2.5 squared divided by 0.75, which equals 60.8. 60.8 Newton is the answer to that question. Is to solve numerical problems from angular projectile motion. Example 2 from page number 146 of your textbook. A ball is launched at 4.5 meter per second at an angle 66 degree above the horizontal. It starts and lands at same distance from the ground. What are the maximum height and flight time? So first we will draw the diagram for this projectile motion. So this is an angular projectile motion. So first I will draw the ground here. So from here you are throwing the ball. So this ball is following a trajectory like this in the shape of a parabola. So the ball is launched at 4.5 meter per second at an angle 66 degrees. So this angle, that angle is 66 degree. This angle is 66 degree and the ball is launched from here and its initial velocity is 4.5 meter per second. And we need to calculate the maximum height. So we need to calculate the maximum height delta y, that we need to calculate, and we need to calculate the total time taken, the flight time. So here we know that a projectile has both horizontal motion and vertical motion simultaneously. So the first step that I told you what to do here, first you need to write. So we draw a table like this. So here we will write the horizontal motion and here we will write vertical motion. Then we will write what is given in the question. So in horizontal motion there are three things. One is horizontal velocity Vx, horizontal displacement delta x, and the time taken, the time of flight t. And here we will write the vertical motion. In vertical motion we will write the vertical initial velocity. This is actually Vyi, but in simple I am writing initial velocity. We know that, right? This side we are vertical, so I am not writing y here, otherwise it will be Vyi. Vertical means initial velocity along the y direction, then initial velocity, final velocity, acceleration, vertical displacement, and the time of flight that we will write here. So what is the velocity along the horizontal direction? Initial velocity along the horizontal direction. Initial velocity is 4.5 meter per second, but that is not along the horizontal direction, not along the vertical direction. This initial velocity makes an angle 66 degree from the horizontal. So first we will resolve that velocity, means we will split this velocity 4.5 meter per second into its horizontal component and vertical component, the x component and the y component. So horizontal component of that velocity I will draw like this, that is equal to 4.5 multiplied cos 66, right? Horizontal will be always cos and vertical will be always sine. So its vertical velocity means the y component or the vertical component of this velocity, that will be equal to the velocity multiplied sine 66. The horizontal will be cos 66, cos the angle, and the vertical will be sine of the angle. So now we will calculate that. So 4.5 multiplied cos 66, which equals 1.8. So the horizontal component of the velocity, that is 1.8 meter per second, that we will write here, and the vertical component of the initial velocity, that is Vyi. Okay, to simplify it, to simplify the writing, I am just writing Vi. So this is actually the initial velocity along the vertical direction. So 4.5 multiplied sine 66, which equals 4.1. So this value is 4.1 meter per second, and the horizontal distance, that is not given, time not given. So here final velocity at maximum height. Whenever we solve angular projectile motion in numerical problems, we take up to the maximum height. We will not take the complete motion. Okay, what we do is we always take the half of the motion, then we do the calculation. So here so we are taking half of the motion from here to here. When the object reach maximum height, its vertical velocity, okay, this is actually means velocity, final velocity along the vertical direction. So to simplify writing, so I am just writing the final velocity. Okay, it represents final velocity along the vertical direction, that is 0. So we have final velocity is 0. Acceleration will be always negative 9.8 meter per second squared. Maximum height not given. Time is also not given. So here we need to calculate the maximum height. We need to calculate the delta y, right? Delta y, that is what we need to calculate. So here delta y is the vertical height, right? So we don't have to check here, okay, because we need to calculate the vertical height. So we will focus here the vertical data, the data given in the vertical direction. So delta y, that is the maximum height, the vertical displacement, which equals, so in out of this 1 2 3 4 5, out of this 5 you need to calculate delta y. And what is not given? Time is not given. If time is not given, you will use an equation in that time should not be there. So here you will use this equation, okay, because in this equation you can see there is no time. So we will use to calculate delta y, we will use that equation. We will write final velocity squared, that is equal to initial velocity squared, plus 2 multiplied acceleration multiplied delta y. Final velocity is 0, right? So 0 squared is 0. Initial velocity how much? 4.1. So initial velocity here, when you are calculating the vertical height, you need to use the initial velocity along the vertical direction, means the y component, the vertical component of the initial velocity. Why I am repeating that? Because you should not use 4.5. 4.5 is not the velocity along the vertical direction. What is the velocity along the vertical direction? This velocity, right? That is equal to 4.1, means the y component or the vertical component of the given velocity. So here 0, that is equal to initial velocity along the vertical direction, that is 4.1 squared plus 2 multiplied acceleration is negative 9.81 multiplied the delta y. So I will just write the delta y there. So you want to calculate delta y, so we will take this equation to this side. So the equation become like this: delta y, that is equal to 4.1 squared divided by 2 multiplied 9.8 equals, say 4.1 squared divided by 2 multiplied 9.81. Then what happens to this negative sign? When you take this term to this side, the negative changes to positive. So 4.1 squared divided by 2 multiplied 9.8, which equals, so I am getting 0.86 meters. 0.86 meters. So now we calculated the delta y, right? We got the value of delta y, that is 0.86 meters is the maximum height. So what is the value of delta y? 0.86 meters is the maximum height reached by the ball. And in that question, in the same question, you need to calculate the time of flight, means the total time taken, the time taken to travel for the ball from here to here. So time also, we never calculate the total time. Here we are not going to calculate the total time. What we are calculating? We will calculate half of the time. We will calculate the time taken to reach maximum height. Then we double the time. Calculate time to reach maximum height, then double the time. Why? Because time taken to reach from here to here will be equal to time taken to reach from here to here. So we calculate time taken by the ball to travel from here to the maximum height, and we double that time, so we get the total time. So we know the initial velocity along the vertical direction and final velocity along the vertical direction. So to calculate the time, we will use this equation, okay, the equation number 1. So in the equation number 1, we have final velocity, that is equal to initial velocity plus acceleration into time. So what is the value of the final velocity when the object to reach maximum height? The velocity along the vertical direction, that is 0. So final velocity is equal to 0. Initial velocity along vertical direction is 4.1. So 4.1 plus acceleration will be always negative 9.8 into time. So we need to calculate time, right? So take this 9.8 into t to this side of the equation. So it become 9.8, means positive changes, so negative changes to positive when it is crossing the equal to sign. So 9.8 multiplied time, that is equal to 4.1. So time is equal to 4.1 divided by 9.8. So what's the value? 4.1 divided by 9.8, which equals 0.42 seconds. So this is the time taken to reach the maximum height. So what is the total time? The time of flight. Time of flight means the time for which object is in flight, means the time for which object is in the air. So that time of flight will be equal to double this time, right? 2 multiplied 0.42, that is equal to 0.84 second. 0.84 second is the time of flight, the time taken by the ball to travel from here to here, means to complete its journey, to travel in a parabolic path. So here what did we calculate? We calculated the maximum height and we calculated the time taken. How did we calculate maximum height? Maximum height we calculated using this third equation. Why did we use third equation? Because time is not given in this question. And after that we calculated the time taken using this equation. First we calculated time taken to reach maximum height, then we double the time, so we get the total time in an angular projectile motion. So remember, in an angular projectile motion we always do the calculations to half of the motion, okay? From the starting point to the height we consider half of the motion and we do the calculation. Then for the time value we multiplied the time by 2, means we double the time. The next question, in angular projectile motion, that is, a player kicks a football from the ground level with an initial velocity 27 meter per second. So here also we will draw the ground. So this is the ground level and a player kicks a football. So the football takes a parabolic path like this. So what is its initial velocity? The initial velocity is 27 meter per second. So here the ball is kicked here. The initial velocity is 27 meter per second. And what's the angle? It makes an angle 30 degree from the horizontal. So the angle is 30 degree from the horizontal. Find each of the following. So that to calculate, before we do the calculation, what we draw is, first we draw the two columns. So here we will write the horizontal motion and here we will write the vertical motion. So in horizontal motion we will write horizontal velocity Vx. So I will just write here Vx delta x and the time of flight. So here we will write initial vertical velocity, final vertical velocity, acceleration, vertical displacement, that is height, and time we will write here. So what are the things that is given in this question? So here 27 meter per second, that is the initial velocity, but that is not the velocity along the horizontal direction, not the velocity along the vertical direction. It is a velocity that makes an angle 30 degree from the horizontal. So it is not Vx, not Vy. So first what we will do is we will calculate the Vx, the horizontal component of this velocity. That will be 27 multiplied, horizontal will be always cos, right, cos 30, and its vertical component will be 27 multiplied what, sin 30, right? Okay, so we will calculate and we will write the answer for that. So 27 multiplied cos 30, which equals 23.4. so its velocity along the horizontal direction, that is 23.4 meter per second, that is the initial velocity along the horizontal direction, and the initial velocity along the vertical direction 27 multiplied sin 30, so which equals 13.5. the velocity along the y direction, that is 13.5 meter per second. Then next, the horizontal distance traveled not given, so which is not given, the time of flight not given in the question. So final velocity, we told, right, that we always take that motion up to the maximum height. So when the object reach up to at the maximum height, the final velocity will be 0, right? At the maximum height, the vertical velocity will be 0. So we are considering half of the motion. We are considering motion of the ball from here to the maximum height. So the velocity at maximum height is 0. That is our final velocity, and 0. Acceleration will be negative 9.8, always in projectile motion, and the maximum height is not given, time is not given. So question A, in that the ball's hang time, we need to calculate the total time here. So to calculate total time, the ball's hang time means the time of flight, the time for which the object is in the air. So what we will do is we will take this equation to calculate the time. So first we will calculate the time taken to reach maximum height, means half of the time we are calculating. After that we will double the time, so we get the total time. So I will take this equation, final velocity, so we will write here to calculate time. So we need to calculate the flight time, means the hang time. So to calculate time, what we are doing is we are taking this equation, final velocity, that is equal to initial velocity plus acceleration multiplied time. So final velocity is 0, initial vertical velocity is 13.5, acceleration will be always negative 9.8, and multiplied time t. So we need time, right? So I will just rewrite this equation. So time becomes equal to 13.5 divided by initial velocity plus, okay, so it will be plus 13.5 divided by 9.8, which equals 13.5 divided by 9.8 equals 1.38. So 1.38 second, that is the time taken to reach the maximum height. So what is the total time? So total time is means the time of flight, okay, the hang time, the time for which the object is in the air, that is 2 multiplied 1.38, so which is equal to 2.8, right? 2 multiplied 1.38 equals 2.76, so 2.8 seconds. So now we got the total time, right? So we got the time, that is 2.8 second is the time of flight. So here 2.8 second is the time of flight, the hang time. Then what else we need to calculate? We need to calculate the ball's maximum height. So in the last question also we calculated the maximum height delta y. How did we calculate delta y? We calculated the maximum height using this equation, using the third equation, right? Here we have time, so we can use the second equation also, but in that case we will have to solve the equation, okay? So better to use the third equation to calculate the maximum height, because we know the value of the initial velocity and value of the final velocity and acceleration. So to calculate maximum height, we will use this equation, that is final velocity squared is equal to initial velocity squared plus 2 multiplied acceleration multiplied delta y. So final velocity will be always 0 for a projectile motion, because we are considering final velocity is the velocity at maximum height, and initial vertical velocity is 13.5. So 13.5 squared plus 2 multiplied negative 9.8 multiplied delta y. So delta y, that is the vertical height, which equals 13.5 squared divided by 2 multiplied 9.8, which equals 13.5 squared divided by 2 multiplied 9.8 equals 9.3 meters. So the maximum height, the height reached by the ball that you kicked, is equal to 9.8 meter. How did we calculate height? Using this equation. Okay, to calculate the height reached, you can usually use this equation, because you know the final velocity will be always 0 for an angular projectile motion, because final velocity is the velocity at maximum height. So at a maximum height, the vertical component of the velocity is 0 and height is vertical displacement, right? So to calculate the height, we will be using the vertical component of the velocity. Then next is next question, see, the horizontal distance the ball traveled before hitting the ground. So what is the horizontal distance traveled by the ball? Now I will erase this to calculate the horizontal distance traveled by the ball. So horizontal distance traveled by the ball, that we represent by delta x, and to calculate the horizontal distance traveled, we have only one equation. There is only one equation in projectile motion to calculate the horizontal distance traveled, means how far the object is moved. So horizontal distance traveled is Vx, that is horizontal velocity, into time. This time is time of flight, the total time. So here, what is the value of the horizontal velocity, means velocity along the horizontal direction? That is 23.4 meter per second, and that is constant throughout the motion, right? So 23.4 multiplied the flight time, the total time, the time taken by the ball to travel from here to here, that is equal to 2.8 seconds. So 23.4 multiplied 2.8 equals 23.4 multiplied 2.8 equals 65.5. 65.5 meter is the horizontal distance traveled. It is the distance traveled by the ball, which means this distance. Okay, this distance, that is equal to how much? 65.5 meters is the distance from here to here. That is the horizontal distance traveled by the ball. How did we calculate that? To calculate the horizontal distance traveled, there is only one equation, that is delta x equal to Vx into t. What is Vx? That is the component of the velocity along the horizontal direction. How to get that? We get that using like cos theta, the given velocity multiplied cos of this given angle. Question number 18 is about vector addition. So in vector addition, there are some rules that you need to know. First one is, if there are two vectors in the same direction, if vectors are in the same direction, you need to add. So if the vectors are in the same direction, you need to add. If the vectors are in the opposite directions, to find the resultant you need to subtract. And third, if the vectors are perpendicular, perpendicular means angle between them is 90 degree, then you need to use Pythagorean theorem. Okay, Pythagorean theorem. Then if the vectors are at an angle that is non-perpendicular, means the angle is not equal to 90 degree, non-perpendicular. If vectors are non-perpendicular, then you need to use law of cosine or law of sine to calculate the resultant. You need to use law of cosine. So you have two methods, right? One is you need to use law of cosine, or you need to use law of sine. When to use law of cosine? Law of cosine you can use if two sides and one angle given. If two sides and one angle given. And you can use law of sine when one side and two angles given. So these are the basics of vector addition. Now we will discuss the questions, means how to solve the numerical problems from this vector addition. Question number 1. A car is driven 25 km due west. So first we will draw this here. So this is the north side, south side, west and east. A car is driven 125 meter due west. So 125 meter, so 125 kilometer, 125 kilometer towards west, then 65 kilometer due south. After that 65 kilometer, so 65 kilometer will be shorter than 125. Okay, 65 kilometer due south, and you need to calculate the resultant. The resultant will be always from the starting of the vector to the end of the vector, from the starting to the end. So this is the resultant, right? How to calculate resultant? Here you can see the angle between these two vectors is 90 degree. So vectors are perpendicular, right? If the vectors are perpendicular, then the magnitude of the resultant, that is equal to square root of 125 squared plus 65 squared equals square root of 125 squared plus 65 squared equals 140.8. so 141 kilometer. That is the resultant displacement. That is the resultant of this two displacement. And what about the this is the direction, right? So what about this angle made by the resultant from the x-axis or from the horizontal? So angle made by the resultant from the horizontal, you need to calculate the angle theta, that is equal to tan inverse y by x. Angle is always use that equation, okay, tan inverse y by x. So tan inverse, what is the value of y component or the vector along the y axis? That is 65, right? 65 over which one is along the x axis? X axis is 125. Or we say like this, tan inverse opposite side over adjacent side. What is the opposite side? 65 kilometer, and adjacent side is 125 kilometer equals how much? Shift to tan. So you get tan inverse 65 over 125 equals 27.5 degree. 27.5 degree. So this resultant makes an angle 27.5 degree from this horizontal. The second question in vector addition, Fahad walks 0.4 kilometer in a direction 60 degree west of north and then goes 0.5 kilometer due west. What is his displacement? So we will first draw the diagram here. So if I just draw the directions like this, so this is the north side, right, south, west and east. So Fahad is walking a distance of 0.4 kilometer in a direction that is west of north, 60 degree west of north. So Fahad is walking like this. He is walking 60 degree west of north and he is walking 0.4 kilometer along that direction. Then he is walking 0.5 kilometer to the west. So after that he is walking 0.5 kilometer to the west. So 0.5 kilometer along this direction, 0.5 kilometers. So the question is to calculate the displacement or Fahad's displacement. So displacement is from the starting to the end, right? From the tail of the first vector to the head of the second. So there is a bend here. Okay. So this is the resultant. We need to calculate resultant. So angle between these two vectors, you can see that is not equal to 90 degree, which means these vectors are non-perpendicular vectors. So to calculate the resultant of non-perpendicular vectors, you can use cosine law. Why cosine law? Because we know the two sides and one angle. So what is the value of this angle? So you can see here, this is 60 degrees. So This angle will be 60, this will be 90. 90 plus 60 is 150. So this angle will be 150 degree. So now we know two sides and one angle, the value of two sides and one angle. So use the cosine law, that is R is equal to resultant is equal to square root of 0.4 squared plus 0.5 squared minus 2ab cos theta, right? Cosine law, what is cosine law? A square plus b square minus square root of a square plus b square minus 2ab cos theta. So 2 multiplied 0.4 multiplied 0.5 multiplied cos the angle is 150 degree. So I will tell how did we get the angle 150. So if this angle is 60, then you know the z angle, right? Z angle. So if this is 60, this will be 60, and this is 90 degree. So this 90 plus this 60, this 90 degree plus 60, up to here 90, this is 60. So 90 plus 60, so we get the total angle 150. So here then you just use your calculator and do the calculation. You will easily get the answer. So very simple. 0.4 squared plus 0.5 squared minus 2 multiplied 0.4 multiplied 0.5 multiplied cos 150. So I am getting 0.87. So his Fahad's displacement is 0.87 meters. So what is the angle of this displacement? How to find this angle? Angle made by the resultant Then how to find the angle resultant makes with the x-axis? The angle made by the resultant with the x-axis, that is this angle. So this angle will be equal to this angle, right? So we need to calculate this angle, okay? Angle of this one means the resultant with the x-axis. So to find that angle, we will use sine law. To find the angle or to find the direction of the resultant, we will use the sine law. Sine law states that side divided by sine of the opposite angle will be equal. So we have here two sides, right? And we have this angle, and we need to calculate this angle, right? So to calculate that angle, so I will write the sine theta, sine of this angle, divided by the opposite side. Which side is opposite to this angle? This side is opposite, right? So 0.4 sine theta divided by 0.4, which equals the other angle. We will take another angle, that is the angle that we know, that is 150, right? So sine of that angle 150 divided by the value of the opposite side. Which side is opposite to this angle? This side, right? This one in red color. That is our resultant that we calculated, 0.87. So we want to calculate the theta. So first we will write sine theta, that equals sine 150 multiplied this 0.4 will go to the other side, 0.4 divided by 0.87 equals sine 150 multiplied 0.4 sine 150 equal multiplied 0.4 divided by 0.87, so equals I am getting 0.23. We need the angle, right? So to calculate the angle theta, sine inverse this value 0.23, sine inverse 0.23 equals, so we get the angle, shift sine, so we get sine inverse 0.23, so I am getting 13.3 degree. So this resultant make an angle 13.3 degree with the x-axis. That is how we calculate the angle. So first we calculated this angle, okay. So this angle and this will be equal, right, because it is z angle. The next question in vector addition, that is two ropes tied to a tree branch hold up a child swings. So the swing exert, there are two forces acting on the swing. So here the swing that we will represent by this dot, the system we are representing by dot, and there are two forces acting on the swing. One force is acting to this side and the second force is acting to this side, and the value of these forces are 2.28 Newton, and this force is also 2.28 Newton. And here the angle is given. So this angle is given as 13 degree and this angle is also 13 degree. So how to calculate the resultant? We need to calculate the resultant force acting on the swing. There are two methods to calculate the resultant. First one is by using cosine law. So we will draw this vector. I will draw like this here. So this is 2.28 Newton force, and the second force that we will draw here, like this. The second force is also 2.28 Newton. So we are drawing tail on head, tail of the second vector on the head of the first vector. So the resultant will be like this. The resultant will be along this direction. So this will be the resultant R, that is what we need to calculate. So here we know the values of two vectors and we have to know this angle. So how much will be the angle? So here this angle is 13 degree and this angle is also 13 degree. So the total angle will be 26 degree, right? So this angle is 26 degree, which means like this, right? So this angle is, this total angle is 26 degree. This total angle is 26 degree. If that angle is 26 degree, then this angle will be also 26 degree. 26 degree. So this you can see here, this total angle will be 180 degree, right? This is 180 degree. If this is 26, this will be 154 degree. 154 plus 26, that will be 180 degree. So like this total angle will be 180 degree and this one will be 26. So this angle will be 180 minus 26. So I will get 154 degree. So now we know the value of the one vector, the value of the second vector, and we have one angle. So we will use law of cosine. The resultant is equal to square root of a square plus b squared minus 2ab cos theta. So 2.28 squared plus 2.28 squared minus 2 multiplied 2.28 multiplied 2.28 multiplied cos the angle 154, which equals, when you calculate that on square root of 2.28 squared plus 2.28 squared minus 2 multiplied 2.28 multiplied 2.28 multiplied cos 154 equals 4.4 Newton is the value of the resultant force. Then next, what is the second method? So second method is by resolving this vector. So this is the angle, right? So this angle is 13 degree and this is also 13 degree. So if this so we will divide, okay, we will divide these forces into x component and the y component, and this force also we will divide into x component and y component. This force we will divide into its x component and its y component. Means we are dividing each forces into its x component and its y component. So what will be the value of this? If this angle is 13 and this will be, for example, total is 90 degree, right? So 90 minus 13 will be 77 degree, right? So this side will be 2.28 cos 77, and this will be 2.28, means y component of this one, right? The vertical component of this force, 2.28 multiplied sine 77, and this force will be, means this force, okay, this one and for example this is 2. So first force we divided into x component and y component. X component is 2.28 multiplied cos 77 and y component is 2.28 multiplied sine 77. That is, x component is always cos and y component is sine. How did we get to 77? This total angle will be 90 degree, right? So if this angle is 13, then the remaining angle will be 90 minus 13, that is equal to 77. Then next we are dividing this vector, means the second force, into its x component and y component. X component will be, so same like the other one. Here this angle, if the total angle is 90, this is 13, so this will be 77 degree, right? So what will be the x component? X component will be cos, right? So 2.28 multiplied cos 77, and y component will be this also, 2.28 multiplied sine 77. So here you can see the x component of both the forces, x component of the first force and the x component of the second force, they are equal, right? 2.28 multiplied cos 77, this also 2.28 multiplied cos 77. They are equal, but they are in the opposite direction, so they cancels each other. They are equal and opposite, so they balance each other, they cancel out. So what is remaining? Only the y component is remaining, right? Because they are in the same direction. The y component of the first force and the y component of the second force, both are in the same direction, so we need to add. So the resultant will be, resultant force is equal to, we need to add both, right? 2.28 multiplied sine 77 plus 2.28 multiplied sine 77, or we can just write 2 multiplied 2.28 into sine 77 . 2 multiplied 2.28 multiplied sine 77 equals what? Equals 4.4, the same answer we will get. So these are the two different methods, okay, to solve this question. 4.4 Newton. The next question, that is question number 19, is to calculate tension, force and normal reaction. So in that first question, a block hangs from the ceiling by massless rope. A second block is attached to the first block and hangs below on it another piece of massless rope. If each of the two blocks has a mass of 5 kg, what is the tension in each rope? So this question is to calculate the force of tension. The question is to calculate force of tension. The question is, we have a a string here and we attach a block here. And what is the mass of the block? 5 kilogram is the mass of the block. Then from here another string and again another block is attached here. Its mass is 5 kilogram. So what is the tension in each string? So here we have one string. This tension we will write T1, and here we have the second string. This tension we will write T2. So what is the tension in each string? So we will calculate, first we will calculate the tension in this string T2. So here you can see how much mass the T2 is supporting, T2 is holding, or what is the total mass hanging on this string, the second string. 5 kilogram mass, right? Or you just check how much mass is below this string. How much mass is below the string? 5 kilogram mass. So tension is equal to weight of that mass, means 5 multiplied 9.8. 5 multiplied 9.8. 5 multiplied 9.8, which equals 49 Newton. 49 Newton is the tension in the in this second string. So tension will be acting in the upward direction, right? Why? The weight is pulling the string downward, so tension will be acting in the upward direction. This string will be applying an upward force on this mass. So how did we calculate this? You need to check how much mass is below the string. So you can see below this string, there is a 5 kilogram mass. So tension is equal to 5 multiplied 9.8. So how to calculate tension in the first string, in this one, that you can tell. You tell how much mass is below the string, the total mass below the string. So you can see here 5 kilogram. Then after that there is a 5 kilogram here also. So 5 plus 5 multiplied 9.8. The total mass below the string multiplied 9.8, or we can say tension is equal to the weight of the total mass below the string or supported by the string. So 5 plus 5 is 10. 10 multiplied 9.8, that is equal to 98 Newton. So this is how you need to calculate the tension. Then I will give another example for tension, to calculate tension in another situation. So here we have two string, like this. We have two string and we have one block. So mass of this block is, for example, again we will take 5 kilogram. Even the size is bigger, I am writing 5 kilogram. So there will be tension here and tension in this string. So to calculate tension in each string, what is the tension in each string? So here you can see there are two tension, right? 2T, that is equal to the weight of the mass supported, or weight of the mass that is hanging from this string, that is 5 multiplied 9.8, which is equal to 49 Newton, right? So tension T equal to 49 divided by 2. Why 49 divided by 2? 49 divided by 2 will be 24.5 Newton. Why 49 divided by 2? Because its weight is supported by two strings. So tension in each string will be equal to 24.5 Newton. Another question: a block hang from the ceiling by a massless rope. A 3 kilogram block is attached to the first block. So the question is like this. So here we have a ceiling, and from the ceiling a string. So here we have a mass M that is not given, and another mass is also attached like this, and this mass is 3 kilogram. So what is given in this 3 kilogram is attached to the first block and hangs below it on another piece of massless rope. The tension in the top rope is, so here the tension is equal to 63 Newton. Tension is equal to 63 Newton. The tension in each the top rope is 63 Newton. Find the tension in the bottom rope and the mass of the first block. So we need to calculate this one. Okay, we need to calculate this T2 and we need to calculate this value of the mass. So how to calculate T2? It's very easy, right? T2 is equal to, you need to check how much mass is hanged by or how much is mass is below this string. Below that string there is only 3 kilogram mass, so 3 multiplied 9.8, which is equal to, how much is 3 multiplied 9.8? 3 multiplied 9.8 equals 29.4 Newton. 29.4 Newton. Then we need to calculate the mass of this. So here, so what we will do is, first we will calculate this. T1 is given, right? So T1 minus T2, that is equal to weight of this mass, right? Weight of the mass, T1 minus T2, that is 63 minus 29.4, which equals 63 minus 29.4 equals 33.6. 33.6 Newton is the tension because of this mass. 24.9 is the tension produced by this mass. So how much tension is produced only by this mass? That is only by the mass m, that is equal to 33.6 Newton. So mg, the weight of that mass, is 33.6 Newton. You need to calculate the value of the mass, right? So m is equal to 33.6 divided by 9.8 equals 33.6 divided by 9.8, which equals 3.4 kilogram. So that mass is equal to 3.4 kilogram. The next question is to calculate normal force. A 6 kilogram block rests on top of a 7 kilogram block. So here we have a 7 kilogram block. 7 kilogram block. On 7 kilogram block there is another block. Its mass is 6 kilogram. So here we have a 6 kilogram block. What is the force exerted by 7 kilogram block on 6 kilogram block? So how much is the normal force acting on the 6 kilogram block by the 7 kilogram block? To calculate normal force, we know that normal force is equal to mg. So how much is the mass of this 6 kilogram, right? 6 multiplied g is 9.8. 6 multiplied 9.8, you will get the value of the normal force acting on the 6 kilogram mass. 6 multiplied 9.8, which equals 58.8. So 58.8 Newton, that is the normal force acting on the 6 kilogram block. Then the next question, question number 20, that is from circular motion, to calculate the centripetal force and centripetal acceleration. Those questions we have already discussed in the previous questions. So we have finished discussing all the 20 questions from the EOT, means end of term examination, end of term 2 physics examination for grade 9 advanced. And at the end I want to discuss two things. One is about the normal force and second is about the inclined plane. So how to calculate the normal force? Okay, to calculate this, so this is not from question number 19. To calculate the normal force, for example, number 1, if the object is on a horizontal surface, for horizontal surface, for a horizontal surface, normal force will be always equal to mg. Normal force is always equal to mg if there is no applied force. If you are not applying any force on the object. Then number 2 is a normal force on an inclined surface, on an inclined surface, normal force is always equal to mg cos theta. Mg cos theta, that is the equation to calculate normal force on an inclined surface. Then number 3 is, it's like here is an object and you are keeping on the object on this floor, and what are you doing? You are applying a force, okay? You are applying a downward force on this object. You are pushing this object downwards. So this is the applied force. In that case, normal force is equal to, in such case, means if there is an applied force, then normal force is equal to mg plus the force you are applying if you are applying force in the downward direction. And in another case, like for example, here is the object, on the floor there is a block here, and you are applying a force on it, and the force is applied in the upward direction. So in that case, if you are applying a force in the upward direction, in that case normal force, that is equal to mg minus the force you applied.